Welcome to the deep dive. Today we're tackling MLOps. Sounds kind of technical, right?
It does a bit, yeah. But think of it like this. You take machine learning, add in the practices from DevOps for reliability, mix in some solid data
You
engineering.
get what exactly?
You get a system. A way to actually get AI models working in the real world reliably, efficiently, and keep them working.
Okay, so not just building the model, but the whole journey, from data collection, training, all the way to keeping it updated.
Exactly that. The entire life cycle.
Gotcha. And for you listening, maybe you want to get a real grip on what MLOps is, why it's suddenly everywhere in AI, but without, drowning in textbooks.
That's the plan. We're using a really good introductory text as our guide today. It covers the main ideas, the life cycle data stuff, model building, deployment, the whole 9 yards.
And best practices, too.
Oh, yeah, crucial stuff. So our mission today, give you a clear view. What is MLOps? Why should you care? And what are its key parts?
All right, MLOps. Beyond the buzzwords, let's break it down. What does it really mean day to day?
Okay, so picture this. You've got brilliant data scientists, right? Building amazing models.
Yep, in their labs, doing cool stuff.
Exactly. But then you need to get that model out there, running in an app, making predictions for actual users.
Yeah.
That's where MLOps comes in. It's the bridge.
The bridge between the lab and, realities.
Pretty much. It connects the science side with the engineering side that needs to deploy and maintain these things. It takes lessons learned from DevOps.
Which made software development way smoother.
Right. Lessons about automation, testing, collaboration, and adapts them for ML's unique quirks.
Quirks like massive data sets, models that aren't just static code.
Precisely. And the fact that models need constant feeding, monitoring, retraining, it's a different beast than traditional software.
So it's like building a Formula One car is one thing, but you need the whole race team, the strategy, the pit stops.
That's a great way to put it, yeah. MLOps is the race team and strategy for your AI models.
And why is that so critical now?
Because businesses are relying on ML more and more. For everything. Big decisions, automating tasks, new features.
So they need it to be reliable, scalable.
Exactly. Without MLOps, you get these lab models that are amazing, but never actually make it into production. Or they do, but then they break. Or their performance tanks quietly.
Ouch. So MLOps brings the discipline.
It brings speed, robustness, reproducibility, maintainability, all the malleabilities you need for serious ML deployment. Think faster rollouts, continuous improvement based on real data, smoother operations.
And keeping things compliant, I guess, with regulations and stuff.
That too, yeah. It helps ensure you're following the rules.
Okay, so we have MLOps, but I also hear about DevOps and data ops. It's an ops explosion. How are they different?
Yeah, it can seem like alphabet soup, but there are clear distinctions. DevOps, as you probably know, is about merging software development and IT operations. Faster, reliable software releases.
Right, streamlining the code to production pipeline.
Exactly. Data ops focuses specifically on the data itself, getting data flowing smoothly, ensuring quality, governance, automating data pipelines.
So MLOps takes pieces from both.
It does. It borrows heavily from DevOps principles like automation and CI/CD, and it relies heavily on data ops for the data foundation. But then it adds layers, specifically for ML.
Like what kind of layers?
Things like model versioning, which is trickier than code versioning. How do you track changes to a trained model artifact? And monitoring for things like data drift, when the real-world data starts looking different from the training data, messing up your model's predictions.
That sounds unique to ML.
It really is.
Yeah.
And ensuring the whole process from data prep to prediction is reproducible, that's huge in ML. So MLOps kind of sits at the intersection, deeply aware of how code, model, and data interact.
So it feels like DevOps was the starting point, but as ML got bigger, people realized, oh, this needs something more.
That's pretty much the history, yeah. DevOps principles became standard for software in the late 2000s, early 2010s. Continuous integration, continuous delivery, infrastructure as code. Huge improvements.
Made software dev much less painful.
Totally. Then, in the last, say, 10 years, ML just exploded. Better algorithms, way more computing power thanks to the cloud, tons of data, great open source tools.
A perfect storm for AI development.
Right, but then people tried applying standard DevOps practices directly to ML workflows.
And it had some snags.
Big time.
Yeah.
It became clear that ML systems are different. That huge reliance on data, the specific version and quality of data, is as critical as the code.
Can't just change the code and expect it to work if the data's off.
Exactly. Plus, ML development is super experimental, right? Lots of trial and error.
Yeah, tweaking models constantly.
And then the need to constantly monitor models in production for performance decay, for that drift issue. And reproducibility, being able to rerun an experiment and get the same result. That's foundational but hard.
So MLOps basically grew out of those specific needs, filling the gaps left by traditional DevOps.
Precisely. It took the DevOps foundation and built ML-specific practices on top.
Okay, so let's get into those practices. What are the core principles driving MLOps?
Well, a big one is adapting CI/CD for ML continuous integration and continuous deployment.
We know CI/CD from DevOps merge code, test automatically, deploy automatically.
Right, but here, CI isn't just about code changes. It's also about integrating changes to the data used for training, or even changes to the model architecture itself. And the automated testing has to check data validity, model performance, things like that.
So the integration part is broader. Code, data, model.
Exactly. And then CD, continuous deployment, automates getting that tested, integrated package, the model and its serving mechanism, out into production. It speeds up iteration massively.
Because you need to update models maybe way more often than traditional software.
Often, yes. Or you need to react quickly if performance drops. Think about it. A UI bug is annoying, sure. But subtle data drift silently killing your model's accuracy, that's insidious. MLOps CI/CD helps catch that early.
Yeah, you can't just push an update and cross your fingers.
Definitely not. Which leads to another core principle, reproducibility and traceability.
Being able to rerun things and track what happened.
Absolutely critical. For science, rerunning experiments. For debugging, figuring out why a model behaves strangely. For auditing and compliance, proving exactly how a model was built and with what data.
How do you achieve that in practice?
It involves meticulous logging of everything, parameters, metrics, code versions, data versions, using version control for everything, code, data using tools like DVC or Git LFS, the models themselves, and thorough documentation.
Sounds like a lot of bookkeeping.
It can be, which is why automation is another key principle, automation and orchestration.
Automating the pipelines.
Yes. Data pipelines, getting data, cleaning it, transforming it, and the model training process itself, scheduling runs, managing dependencies.
So you don't need someone clicking buttons all the time.
Right, and that's where orchestration tools come in. Things like Apache Airflow or Kubeflow. They act like conductors for your ML orchestra, making sure all the steps run in the right order, handling failures, managing resources.
Okay, makes sense. What about once the model is actually live?
Then it's all about monitoring and logging. Continuous monitoring.
Watching its performance.
Yep. Key metrics like accuracy, prediction speed, latency, but also monitoring the input data for changes that drift detection again. Is the new data looking weird?
And setting up alerts if things go sideways?
Crucial. Alerts for performance drops, data anomalies, system issues, and detailed logging helps you understand why something happened when you're troubleshooting later.
Okay. And the last piece you mentioned earlier, scale. ML needs big resources sometimes.
Huge consideration. Scalability and infrastructure management. MLOps leans heavily on cloud computing for flexible, on-demand resources.
Spin up more machines when needed.
Exactly. And technologies like Docker for containerization.
Packaging the model and its dependencies together.
Right. So it runs the same everywhere. And then Kubernetes for orchestrating those containers at scale, managing deployments, handling load balancing, auto-scaling.
So you can handle lots of users, lots of data.
That's the goal. Efficiently manage the infrastructure to handle the load without breaking the bank or sacrificing performance.
Okay, that gives us a solid grasp of the core ideas. Now, how does MLOps fit into the actual steps of building and running a model? The ML lifecycle.
Right, the life cycle. Usually you think of phases like define the problem, get data, prep data, train model, evaluate, deploy, monitor.
This is pretty linear.
That's the catch. MLOps emphasizes it's not linear, it's highly iterative.
Meaning you loop back.
Constantly. Maybe your model evaluation shows it's not good enough, so you go back to feature engineering or data collection. Maybe monitoring shows performance drift, so you trigger retraining. Or the business needs change, requiring a different approach.
So lots of feedback loops.
Exactly. And MLOps is about managing those loops effectively. Think recommendation engines learning from user clicks, or fraud models retraining on new transaction data daily. MLOps structures that.
It definitely sounds more dynamic than, say, building a website where you might follow a waterfall or agile process, but it feels more sequential sometimes.
That's a good point. A key difference is the shift from being primarily code-centric in traditional software.
Where the logic is in the code you write.
Right. To being data-centric in ML, the model learns from the data, So the data's quality, its features, its volume that often matters more than minor code tweaks. Iterations often involve changing data prep or features, not just the algorithm code.
Interesting distinction.
Another one is uncertainty. ML models give probabilistic outputs, right? Predictions with confidence scores, not hard yes-no answers.
Yeah, it's not deterministic like most code.
And that leads to unique maintenance challenges. Models degrading over time due to drift. That's not something you typically see with standard software rules. MLOps focuses on managing that lifecycle drift.
Let's zoom in on the data part then. It sounds absolutely foundational. How does MLOps improve data management for ML?
It puts a huge emphasis on it right from the start. Data collection and ingestion. ML needs data from everywhere. Databases, websites, APIs, IoT sensors, user logs.
A messy reality.
Totally. So MLOps pushes for automating the ETL processes. Extract, transform, load. Getting that raw data, cleaning it, reshaping it reliably.
Like prepping ingredients before cooking.
Exactly. And deciding if you need batch processing run it nightly or real-time streaming for instant updates. MLOps helps design and automate those pipelines.
With all that data flowing, just keeping track must be hard. Versioning.
Oh, essential. Data versioning and lineage. You need to know exactly which version of the dataset was used to train which version of the model, for reproducibility, for debugging.
How do you version data? It's not like code.
Tools have emerged specifically for this. DVC, data version control, Git, LFS for large files, Pachyderm. They help manage data versions alongside code.
And lineage, what's that?
Tracking the data's journey. Where did it come from? What transformations happened? It's like a data audit trail. Vital for transparency and fixing things when they break.
What about just making sure the data isn't junk? Quality.
Non-negotiable. Data quality and consistency are huge in MLOps. Using data profiling to understand its shape, anomaly detection to spot weirdness, automated quality checks in your pipelines.
Catching bad data before it trains a bad model.
Precisely. And ensuring consistency, the data used for training looks like the data used for testing and the data the model sees in production. Sounds obvious, but it trips up projects all the time.
And rules, regulations, GDPR, privacy.
Yep, data governance and compliance are woven in. Adhering to regulations, managing access control, ensuring ethical use, setting up auditing, MLOps provides the framework to manage this responsibly.
What if you're dealing with truly enormous data sets? Petabytes.
Then you need the heavy hitters.
Yeah.
Big data handling. MLOps incorporates technologies like Apache Hadoop and Spark for distributed processing across clusters of machines.
Breaking the job down.
Right. And for fast-moving, real-time data streams, tools like Kafka or Flink come into play. MLOps helps orchestrate these complex, large-scale data systems.
Okay, solid foundation on data. Let's shift to developing the model itself. MLOps emphasizes collaboration, right? How did that work?
Yeah, model building is rarely a solo act anymore. MLOps recognizes it's a team collaboration. You've got data scientists, ML engineers, data engineers, maybe DevOps folks, project managers.
Different skills, different focuses.
Exactly. MLOps promotes clear roles, shared tools like Git for code, maybe shared notebooks like Jupyter, communication platforms like Slack, project tracking like Jira.
Keeping everyone on the same page.
And using practices like code reviews, maybe even pair programming, to improve quality and share knowledge. It's about breaking down silos.
And all the experiments data scientists run, trying different algorithms, parameters. That seems chaotic to track.
It can be. That's why experiment tracking is a core MLOps practice. Using tools specifically designed for this, like MLflow or weights and biases.
What do they do?
They log everything automatically. The code version, the data hash, the parameters you used, the resulting metrics like accuracy, the model file itself.
So you can compare runs easily.
Yeah.
And go back.
Exactly. Reproduce successful experiments, understand what worked and why. It brings scientific rigor to the process.
And once you have a model you like, you need to track its versions too.
Absolutely. Model version control. Just like code, you need to know which version is which. Often done using model registries, central places to store, version, and manage trained models.
Tied back to the code and data versions used to create it.
Ideally, yes. Complete traceability. This lets you roll back safely if a new model version has problems.
Reproducibility keeps coming up. You said it's tricky in ML.
It is. There's randomness in algorithms, tiny differences in software libraries, or even hardware can change results.
So getting the exact same result twice is hard.
Sometimes impossible, but MLOps promotes best practices to get as close as possible, setting random seeds, using environment managers like Conda to lock down dependencies, meticulous documentation.
Controlling the variables you can control.
Precisely. Managing the environment is key.
What about AutoML? Automated machine learning, does that simplify things or complicate them for MLOps?
Bit of both, maybe. AutoML tools like AutoSclearn, Google's AutoML, can automate stuff like choosing the best model type or tuning its parameters.
Speeds things up, makes it more accessible.
Definitely. Huge potential benefits. But the limitation is often transparency. It can be a bit of a black box. And it might miss nuances a human expert with domain knowledge would catch.
So how does MLOps view AutoML?
As another tool in the toolbox, MLOps helps integrate AutoML outputs into the overall managed lifecycle, ensuring even auto-generated models are versioned, tested, monitored, and aligned with business goals. It's not magic, it still needs governance.
Got it. Okay, model built, versioned, looking good. Time for the big moment. Deployment. Getting it out there.
What are the MLOps approved ways?
Approved ways. It's more about choosing the right strategy for the job. A key distinction is batch versus online serving.
Batch is like running it once a day on a pile of data. Yeah, it's scoring a large data set on a schedule. Think generating daily sales forecasts. Online serving is real-time. A request comes in, the model responds immediately, like a recommendation engine on a website.
Latency matters for online.
Hugely. So the deployment needs to be fast.
And where does the model run? In the cloud. On my phone.
It could be anywhere. Deployment architectures vary. Edge deployment means running on the device itself, your phone, a smart camera, an industrial sensor.
Close to the data source, low latency.
Right. Cloud deployment uses scalable cloud infrastructure. Hybrid mixes both. The choice depends on latency needs, connectivity, processing power, cost, data privacy.
Lots of factors. You mentioned Docker and Kubernetes earlier for infrastructure. How central are they to deployment?
Pretty central for many modern MLOps setups. Docker containerizes the model and its environment, packages it up neatly.
So it runs consistently anywhere.
That's the idea. Then Kubernetes orchestrates these containers, manages deployment rollouts, handles scaling automatically, adding more containers if traffic spikes, and ensures resilience if one container fails.
Like an automated operations team for your model containers.
Kind of, yeah. It handles a lot of the complexity of running applications at scale.
Are there simpler options if I don't want to manage Kubernetes clusters?
Definitely. Serverless deployment is another option MLOps considers. Platforms like AWS Lambda or Google Cloud Functions.
Where you just upload your model code and the cloud provider handles the servers.
Essentially, yes. You pay per invocation or per millisecond of compute. Great for event-driven tasks or things with very spiky traffic, where managing your own servers 24/7 would be overkill.
Okay. And the CI/CD pipelines we talked about for building, they extend to deployment too.
Oh, absolutely. CI/CD for ML deployment is critical, automating the whole flow. Code change triggers tests, builds the container, runs ML-specific validation tests on the model, then deploys it safely.
What kind of ML-specific tests?
Checking model performance against a baseline, ensuring predictions are within expected ranges, maybe even testing for fairness or bias before it goes live.
So more than just does the code run?
Much more. Tools like Jenkins, GitLab CI/CD, GitHub Actions are adapted for these ML deployment workflows.
So the model is live. How do you make sure it can handle, say, 1 million users hitting it at once? Scaling.
Yeah, scaling models is a big MLOps focus. Using load balancers to spread requests across multiple running copies instances of your model.
So no single copy gets overloaded.
Right. And auto-scaling to automatically adjust the number of instances based on traffic. More users. Spin up more instances. Fewer users. Scale down to save costs.
Clever.
MLOps also looks at optimizing the model itself for speed, inference time, and using efficient serving frameworks to handle high throughput and keep latency low. Sometimes even using specialized hardware like GPUs or TPUs for predictions.
Okay, built, deployed, scaled. But models aren't static. They live in the real world now. Monitoring and drift seem crucial here.
Absolutely. Post-deployment is where the real work often begins. Continuous monitoring and logging are non-negotiable.
Watching performance, system health.
Yep. Tracking accuracy, latency, error rates, resource usage, CPU, memory, system uptime. But crucially, also monitoring the data the model is seeing in production.
Looking for that drift again?
Constantly. Is the distribution of incoming data changing? Are there new categories appearing? Tools like Prometheus for metrics collection and Grafana for visualization are common here.
And alerts if things look weird. Plus logs for digging deeper.
Exactly. Robust alerting for anomalies, performance drops, system failures, and detailed logs to diagnose why things went wrong. Good monitoring and logging are your eyes and ears in production.
And when you detect that drift or performance degrades, what's the MLOps approach?
That's managing model drift. First, you need reliable drift detection techniques. Statistical methods comparing production data distribution to training data, or monitoring model prediction confidence.
They'll let you detect it.
Then you need a strategy for retraining or updating the model. Could be scheduled retraining, rebuild the model every week with new data, or trigger-based retrain only when significant drift is detected.
And automate that retraining and redeployment.
That's the goal for mature MLOps setups. Closed-loop automation. Detect drift. Trigger retraining pipeline. Validate new model. Deploy new model. Maybe with some human oversight, but largely automated.
Wow. Okay, that covers the whole life cycle in quite some detail. Bringing it all together, what are the overarching best practices? And maybe a glimpse into the future.
Sure. A key best practice is really about culture. Establishing an MLOps culture. Getting data scientists, engineers, operations, product folks all speaking the same language and collaborating effectively.
Breaking down those silos we talked about.
Yes, and emphasizing documentation, knowledge sharing. Defining clear metrics, not just model accuracy, but deployment frequency, operational stability, data quality metrics, even business impact. And standardizing processes where it makes sense.
Making it repeatable and reliable across projects.
Exactly.
And then there's the whole doing AI responsibly angle, ethics, bias. How does MLOps intersect with that?
Increasingly central, ethical considerations are becoming a core part of MLOps. This includes building in checks for fairness and bias detection during development and monitoring.
Trying to ensure the model isn't discriminating unfairly.
Right. Also, transparency and explainability, using techniques like SAP or LIME to understand why a model makes certain predictions. Accountability through governance and audit trails, MLOps, help provide that. And privacy-preserving techniques like federated learning or differential privacy are sometimes integrated.
So MLOps isn't just about efficiency, it's also about building trustworthy AI.
That's increasingly the expectation, yes.
Yeah.
And related to that is security in MLOps.
Protecting the models.
Right.
The data.
Both. Understanding threats specific to ML systems like data poisoning or model evasion attacks, implementing secure deployment practices, protecting intellectual property in the model, ensuring data privacy and security throughout the pipeline. It's a growing area of focus.
This has been quite the journey through MLOps, super comprehensive. So for you listening, if you had to boil it down, what's the absolute core message to take away?
I'd say MLOps is about bringing professional engineering discipline, rigor, automation, collaboration to the entire machine learning process.
From idea to production and beyond.
Exactly. It's how organizations can actually deliver on the promise of AI reliably and at scale. It tackles the unique challenges ML brings, especially around data and the dynamic nature of models that standard software practices alone don't fully address.
Were there any bits from our chat that you think might be particularly lip-atrizing or maybe sticky for people?
Maybe the clear lines between DevOps, data ops, and MLOps, understanding they solve related but distinct problems.
Yeah, the ops landscape clarified.
Also, perhaps the range of specialized tools available now for experiment tracking, data versioning, monitoring shows how mature the field is becoming, and maybe the growing integration of ethical considerations. It's not just an afterthought anymore.
Right, it's baked in.
Yeah.
So as our listener reflects on all this, what should they be thinking about next? Where could they explore further?
Well, I'd encourage you to think, how could these principles, automation, monitoring, versioning, collaboration around data-driven systems, apply in your own work or field? Even outside direct ML model building.
The concepts are broader, maybe?
I think so. You could also dive deeper into specific tools we mentioned, or look into frameworks for responsible AI, or explore advanced deployment patterns like canary releases or A/B testing for models.
Lots of directions to go.
Definitely. Becoming truly well-informed on MLOps, like any deep topic, is an ongoing journey. Hopefully this deep dive gave you a really solid map to start exploring.